Hello everyone. In this video, I want to give us a quick review on how to make a graph in Google Sheets. So in this example, we are going to be using data given to us here. Distance, we're going to make a distance versus time graph. A graph that probably a lot of us are familiar with, for having a lot of you have taken physics last year. So what I'm going to do is Google Sheets. It's pretty smart. It's a pretty smart program, but it's not smart enough to read through this picture for me. I have to retype out this data myself. So let's go ahead and do that first. Alright, now that I have the directions typed out, I'm going to go ahead and start making my graph. And there's a few different ways to do this. You're going to go to Insert, Chart, but I would recommend, it makes it a little bit easier if you highlight the data and then go to Insert the chart, because this way Google Sheets will go ahead and label the axis titles for you and insert the data into the graph for you instead of you having to manually do that later. So let's do it that way. So we highlighted our data and we go to Insert, Chart, and now we have our graph here. Alright, and now looking at this, let's say Google Sheets, tries to read your mind and it tries to say, hey, this is what we want. We've got time versus distance here. We labeled the title as such, and we put time on the y-axis and distance on the x-axis. And Google Sheets, it's a pretty smart program, but it doesn't always get everything right. So you have to be there to double check things. And so think back to physics last year and say, wait a second, or just any time you've ever seen a distance versus time graph, or any graph involving time. Does time usually go on the x-axis or y-axis? And if you said that time goes on the x-axis, that's actually correct, because time is an independent variable. It is pretty much always an independent variable because we can't control time. We can control the amount of distance that we travel. We can just travel more or less distance, but we can't change the amount of time. We can't pause time or speed up time or slow down time based on us running late. I personally am always running late. Just the other day I was running late to work. Mr. Gibson came up and told me, he said, hey Brad, you gotta start showing up on time. I said, hey, mind your own business. But anyway, I wish that would help me out a lot if I had a stopwatch and pause time based on the amount of distance that I have to travel. But I can't do that, and nobody can. We can't pause time. Time is continuous, and it's just constantly going, and can't change that. But we can change the amount of distance that we travel. So maybe I move to an apartment that's closer to work, and it takes me less time because the distance is different. But I can change the amount of distance that I travel in a said period of time, but I can't pause time. So that's because time is the independent variable and the distance that you can travel is the dependent variable. So the distance that you travel depends on the amount of allotted time that you have, but it's not the other way around. Time does not depend on the amount of distance you have to travel because we can't change time. So hopefully that makes sense to you. Drop a comment or email me if you need more clarification. So that was a very long way to say that time definitely needs to go on the x-axis, so we need to figure out how to redo this chart and have that reflected. So really what happens is Google Sheets saw that we have distance and time written out like this, and all we have to do is if we just switch them and move time over on the left side of our table and distance on the right side of the table, then it'll switch it for us. So let's delete this chart. Let's delete this chart and redo it using time, having time on the left side and distance on the right side. Let's try that. All right, so now we have a new table here. Same data, new table. We just put time on the left side. And we're going to highlight this again and do the same step. Insert, chart, and now let's take a look at what we have. That didn't help us. All right, so I have distance versus time now. So now it's titled distance versus time, and we have time on the x-axis now instead of the y-axis, because again, time is the independent variable. The distance that you travel depends on the amount of time that you have. Distance is the dependent variable. Time is the independent variable. And cool. So we have the graph set up with the correct x and y axes. But if we look at my directions, I was looking for us to have a scatter plot, not a line graph. So we need to change the type of graph that we have here to make it a scatter plot instead of a line graph. So notice that our chart options went away. I'm not sure what I did to get rid of them, but all you have to do to bring them back is you can either double click on your chart, or you can click these three dots and click edit chart. Either one will work. And so we have this chart here, but we don't want a line chart. A line chart is just going to have lines connecting all the data points. I want to see where these individual data points are. That's going to be a lot more useful. So I want a scatter chart. If you're not sure what type of chart to include, in science, the majority of the time you're doing a scatter plot or a scatter chart. Sometimes you're doing a bar graph, sometimes maybe a pie chart. But a line chart, I would say that's kind of infrequent in science. It's usually a scatter chart is probably it's definitely the most common type of chart that I've seen, at least in my experience. So we have a scatter chart now because we changed the chart type to a scatter chart. So now we have the individual data points. That's a lot more useful. Cool, just going through our directions. We now need to worry about the title. And let's look at the title that was automatically generated by Google Sheets. It says distance versus time. Think back to physics again, or any other science class that has had a distance versus time graph. And ask yourselves, well, is it called distance versus time, or is it time versus distance? I've always heard it as distance versus time, so that's how I'm going to have it. I've always heard it as y-axis versus x-axis, but from what I'm hearing from my students the past couple classes is that you guys have been told that it can be either way, so I'm just going to say that it can be either way. But one thing that's I'm going to be a little bit nitpicky about is that this axis title is centered. I've always seen that title centered. I've never seen it on the far left. So we're going to center it. And all you had to do to center it was double click on the title and then go to title format and center it. That's all we had to do. All right, we're going to keep going through our directions here. So we have a scatter plot. We have a title. We already did this. This is one of our first steps. We made sure that the x and y axes are correct. So we have time on the x-axis because it's the independent variable. Units. Since I included units in my chart title here, the units kind of got automatically put on here. But if you didn't have units and you need to put them, all you're going to do is you're going to double click on where the axis title is, and you can go ahead and edit it as you please. Same thing with this one over here. You can edit it by just double clicking on it. Alright, next we need to insert a line of best fit. So let's go ahead and do that. A line of best fit, also called a trend line. So I've got my chart options pulled up, But now I'm going to go over to where it says Customize, and we're going to customize this a little bit. So we're in Customize. We're going to click on Series. And we're going to scroll down. Then there's this button here that says Trend Line. We're going to click it because we want to insert a trend line. So all you have to do to insert a trend line, click this button, and we have inserted a trend line, also called a line of best fit. It's that line that goes through as many dots as possible. That's what a trend line of best fit is. So we have our trend line, and this is useful because it helps us to estimate data points that we didn't actually have. So for example, I collected, or whoever ran this experiment collected these actual data points. They collected that at time 2, a distance of 1 was traveled. At a time of 4 minutes, a distance of 2 kilometers was traveled, etc. But they didn't measure in between. They didn't say at a time of 3 minutes. They didn't take a measurement there. So we can use this trend line to help estimate where those values will lie. So we have, so if I have a time of 3, I can look at where it's at, and we could say, okay, well, it's probably a distance of approximately 1.5. But instead of making an approximation, let's do something one step further, and let's include an equation. So go down to Label and Use Equation. And now we're going to insert an equation for that trend line that we just inserted. So now instead of trying to take a ruler and measure exactly where a time of 3 minutes is, and or where a distance of 1.5 kilometers is, we're going to insert an equation to where we can calculate that and plug in values for either y or x. So we said we want to know how far we're going to travel in 3 minutes. All we would have to do is plug in a value of 3 for x, and we'd get y equals 0.5 times 3 equals 1.5. So this equation, there's something that's a little bit confusing about it, and I don't know why they do that. But in Google Sheets, this equation is kind of shorthanded. I don't know why. But what it means is y equals this. So whatever's shown here on the equation, y equals this. So you might recognize this equation. It's y equals mx plus b, where x is the value that you're going to be plugging in, m is the slope, and b is the y-intercept. And which looks a little bit confusing here because this axis is messed up, so we're gonna fix that in here in just a second. But yes, this equation, it's a little bit confusing because it doesn't say the y equals part, but just know that the y equals comes before this. Y equals 0.5x plus 0. All right, let's fix this x axis. We have right now, I was kind of confused in saying y equals mx plus b, where b is the y-intercept, because it looks like the y-intercept's right here. But notice that for whatever reason, Google Sheets decided that it wanted to start the x-axis with the value of 2. Doesn't make sense to me why they did that, but they did. So we're just going to change insert a minimum value. All we had to do is we had to double click on our x-intercept, and then you're going to type in the minimum value you want, which I don't know why it would be 2. It should just be 0. And then our graph's looking a lot better. We have we don't have the x-intercept randomly starting at a random at the first measured value. Let's just have it start at 0, so that this y equals mx plus b equation matches with the graph a little bit more. Okay, so let's double check through our directions. I think we've gone through everything. We made a scatter plot, fixed the title, made sure the x and y axes were on the correct spots. We have units for each variables, that's what's in parentheses. And we have a line of best fit, aka a trend line, and the equation for the said trend line. So y equals 0.5x plus 0 is our trend line equation. If we want to find any value for, if we want to plug in any value for x, just plug in a value for x here. And then it'll calculate the exact y value where it will fall on that trend line. So pretty useful stuff. There's a kind of, I guess, a review of math a little bit, but it's more of just graph making, which is an extremely important tool in science that we will be using in the future. So make sure you got this down. Hopefully this video has helped. Let me know if you have any questions.